Let's begin with a spacecraft. Not one we can build today. Not one limited by engines, fuel, launch windows, radiation shielding, or the simple fact that matter tends to object when you ask it to do impossible things. Imagine a machine about the mass of a large commercial aircraft. 300 tons of structure, fuel, instruments, shielding, and perhaps, if we are being especially cruel with the thought experiment, a crew that should never have accepted the mission. Now place it in deep space. Ahead of it is Jupiter, not a rocky world, not a planet with a surface waiting below the clouds. Jupiter is a sphere of hydrogen and helium more than 11 times wider than Earth, wrapped in storms, bands, shear zones, ammonia clouds, water clouds, lightning, magnetic fields, and layers that become denser and hotter the deeper you go. Far below the visible cloud tops, hydrogen stops behaving like ordinary gas. Under immense pressure, it becomes a deep fluid. Deeper still, it is forced into an electrically conducting metallic state. There may be a core somewhere inside Jupiter. Rocky, icy, diluted, blurred into the surrounding material by pressure and time. But for this story, the core almost does not matter, because the spacecraft will not reach it as a spacecraft. Now give the spacecraft speed. Not the speed of an airplane. Not the speed of a rocket leaving Earth. Not even the speed of our fastest probes, which already move through the solar system faster than anything humans had built for most of history. Give it 10% of the speed of light. Light moves at almost 300,000 kilometers per second. 10% of that is about 30,000 kilometers per second. At that speed, the spacecraft travels 30 kilometers every millisecond. In less than the blink of an eye, it crosses farther than a city is wide. In a single second, it covers more than twice Earth's diameter. And Jupiter is waiting. If you enjoy these thought experiments where real physics becomes stranger than science fiction, subscribe to the channel. We are going to keep following the universe into places where ordinary intuition stops working. At 10% light speed, Jupiter's upper atmosphere is no longer air in any familiar sense. It is matter arriving too fast for comfort, too fast for engineering, too fast for the idea of a normal crash. The first atoms the spacecraft meets are mostly hydrogen. Tiny, nearly weightless by ordinary standards. But at this speed, every atom striking the front of the ship arrives like a particle from an accelerator. From the ship's point of view, Jupiter's atmosphere is not gently surrounding it. It is rushing upward at 30,000 kilometers per second. There is no normal re-entry. No orange glow building around a heat shield. No neat bow shock like a capsule returning from orbit. Re-entry happens at a few kilometers per second. This is thousands of times more violent. The nose of the spacecraft begins to die first. The atoms hitting it do not simply warm the metal. They smash into it. They strip electrons. They ionize matter. They turn the front layers of shielding into plasma. For a tiny fraction of a second, the rear of the spacecraft has not yet received the news that the front is gone. Mechanical stress cannot travel through the structure fast enough to warn the rest of the ship. The nose becomes radiation and vapor. The middle continues forward. The back continues forward. Then all of it enters the explosion the front has created. At 10% light speed, a 300-ton spacecraft carries roughly 30,000 megatons of TNT in kinetic energy, more than any human weapon ever detonated, far less than the energy needed to damage Jupiter as a planet. Jupiter will not be destroyed. Jupiter will not be meaningfully moved. But locally, the event is enormous. A column of Jovian atmosphere is compressed, ionized, and heated. A brilliant flash blooms in the upper clouds. The path does not look like a clean bullet hole, because Jupiter has no ground to hold one. It looks like a wound made of light, a plasma trail expanding into weather. The ship is gone before it crosses more than a tiny fraction of the planet. Not damaged, not broken, gone. Its atoms still exist, but the arrangement called a spacecraft has ended. Iron, carbon, silicon, aluminum, oxygen, hydrogen, whatever it carried, all of it is mixed into a violent trail of ionized gas and radiation. Now make it faster. Half the speed of light. At 50% light speed, the ship is moving about 150,000 kilometers per second. If Jupiter were empty, the planet's full diameter would pass beneath it in about 1 second. But Jupiter is not empty. At this speed, the spacecraft no longer behaves like an object moving through gas. It behaves like a moving explosion that continuously creates the next part of itself. The atmosphere ahead cannot move aside in any ordinary way. It is crushed, heated, and torn apart almost at the instant it is encountered. Relativity now matters. Not as decoration, not as a science fiction effect. The ship carries more kinetic energy than Newton's formula would predict. Its Lorentz factor is about 1.15. That may sound modest, but with 300 tons of mass, modest relativity is already monstrous. At half-light speed, the kinetic energy is roughly 1,000,000 megatons of TNT. The crew, if we still imagine one, would experience no impact scene, no alarm, no shaking, no last view of the clouds. The timescale is too short. By the time a signal could travel from eye to brain, there would be no eye, no brain, and no spacecraft. The ship drives a channel of plasma downward into denser atmospheric layers. The deeper it goes, the more mass it meets, and the faster its energy is transferred. It is not drilling through Jupiter. It is being converted into heat, radiation, and particle cascades while Jupiter's atmosphere becomes part of the blast. Imagine a needle made of lightning entering a world of gas. For an instant, there is a narrow path of extreme temperature. Then that path expands. Shock waves move outward. Hot material rises. Clouds are punched upward and sideways. Chemical species from deeper layers may be dragged into view. Bright plumes and dark scars could appear, not because any fragment survived, but because Jupiter's weather has been struck by an energy pulse moving at a speed nature almost never delivers on that scale. From far away, Jupiter might briefly brighten. Professional instruments would see the flash easily. Depending on how much energy emerged as visible light, smaller telescopes might see the aftermath. But there would be no crater because there is no solid surface to keep one. The result would look like weather trying to remember an explosion. And still, there would be no wreckage. At ordinary speeds, objects break. At higher speeds, they vaporize. At relativistic speeds, even vapor is an incomplete word. The atoms of the spacecraft are separated, ionized, accelerated, and mixed into the surrounding material. The ship's identity is erased. Now push the speed higher. 99% of the speed of light. At this point, the thought experiment changes character. The Lorentz factor is about 7. The kinetic energy is no longer 1,000,000 megatons. It is tens of millions of megatons. A small object, by planetary standards, has become a delivery system for catastrophic energy. The ship is also in trouble before it ever reaches Jupiter. Interplanetary space is not perfectly empty. It contains dust, gas, ions, and stray atoms. At ordinary spacecraft speeds, these are hazards. At 99% light speed, they become particle accelerator targets. A grain of dust can hit like an explosive charge. A thin stream of gas becomes radiation against the forward shield. But allow the impossible ship to continue. Give it shielding beyond anything we know how to build. Let it arrive mostly intact, or at least intact enough that the thought experiment can reach the planet. Now it touches Jupiter. There are no separate stages anymore. It does not enter, heat, break, and then explode. Those steps overlap so tightly that they become one event. The first atoms of Jupiter's upper atmosphere slam into the spacecraft with enough energy to produce showers of secondary particles. The front of the ship becomes plasma and radiation. The atmosphere ahead becomes a target. The object and the medium stop being cleanly distinguishable. The spacecraft becomes a particle cascade. Jupiter becomes the absorber. If this happened on Earth, it would be a global catastrophe. On Jupiter, it is not enough to destroy the planet. Jupiter is too massive. Its gravitational binding energy is too enormous. The impact energy is spectacular to us, but to Jupiter as a whole, it is still a brief deposit of heat into a world that contains more mass than all the other planets combined. The visible atmosphere, however, would respond violently. A bright flash would appear near the impact point. Space telescopes would see heated gas, expanding shock structures, unusual radiation, and chemistry pulled from layers that are usually hidden below the cloud tops. Jupiter's 10-hour rotation would stretch the scar. Its bands and jets would shear it. A plume might become a streak. A dark mark might wrap around the planet. For weeks, months, perhaps longer, Jupiter could wear the evidence. But the spacecraft would leave no recognizable part. No engine bell. No black box. No metal plate. No crash site. Only energy, direction, timing, and diluted chemistry. Now take the final step. 99.9999% of the speed of light. This is so close to light speed that the Lorentz factor is in the hundreds. The spacecraft still has only 300 tons of rest mass in its own frame. It has not become heavier to itself, but to Jupiter and to any outside observer calculating the energy that must be absorbed, it arrives with billions of megatons of TNT in kinetic energy. That is the heart of the nightmare. The object is small. The consequence is not. By now, the journey itself would be almost impossible. Dust grains would be catastrophic. Interplanetary atoms would become a beam of high-energy impacts. Radiation ahead of the ship would be blue-shifted and concentrated forward. The universe would no longer feel empty. It would feel like something the spacecraft had to survive. But thought experiments allow impossible travelers. So the ship arrives. At contact, the leading edge triggers an extreme cascade of particles. Atomic nuclei collide at energies far beyond chemistry, far beyond ordinary heating, far beyond structural failure. Matter is stripped down. Radiation bursts outward. The atmosphere along the path is compressed and heated so violently that it behaves less like air and more like a target struck by an astrophysical jet. It is tempting to say the spacecraft punches through Jupiter, but that is the wrong image. Punching through suggests that the object remains intact long enough to cut a tunnel. It does not. The spacecraft is destroyed almost immediately. What continues forward is not the ship itself, but the energy and particle cascade produced by its destruction. The blast would radiate across visible light, ultraviolet, X-rays, and high-energy particles. Charged particles would interact with Jupiter's magnetic environment. Radiation belts could be disturbed. Auroral regions might brighten, not as a beautiful decoration, but as a physical response to a sudden injection of charged particles and energy. Could it start fusion? At the smallest scales, individual nuclear reactions could occur in the hottest and most compressed regions. At these energies, some nuclei will collide hard enough for reactions that do not happen in normal atmospheric gas. But this is not the same as turning Jupiter into a star. Jupiter is far too small to sustain stellar fusion. It does not have enough mass to ignite like the Sun. No impact from a 300-ton object, no matter how absurdly fast, changes that basic fact. Jupiter does not become a star. It does not split open. It does not explode as a planet. It absorbs. That is Jupiter's answer to almost everything. It absorbs the ship's atoms. It absorbs the shock. It absorbs the heat. It absorbs the radiation into an atmosphere so vast that even an absurd event becomes, eventually, weather. Not ordinary weather. Not mild. The immediate aftermath would be spectacular. A flash across interplanetary distances. Heated gas rising, spreading, cooling, and mixing, waves circling the planet. Dark and bright features stretched by winds that have been moving for longer than human civilization has existed. But Jupiter would continue rotating. Its storms would continue. Its bands would shear the scar. The Great Red Spot, if still present in this imagined future, would keep turning somewhere else on the planet, indifferent in the way only a storm larger than Earth can be indifferent. And the spacecraft? The spacecraft ended at contact. At low speeds, we can talk about objects. A stone hits a pond. A meteor hits an atmosphere. A spacecraft crashes into a planet. These sentences make sense because the objects remain distinct long enough for our minds to follow them. At high enough speed, the object's identity does not survive. The ship is not a thing that travels through Jupiter and stops somewhere. It is a pattern of matter carrying energy. When that pattern meets enough other matter, it dissolves into a new pattern: plasma, radiation, shock waves, heat, and chemistry. The atoms continue. None of them remember the mission. If a civilization could build something like this, would you allow it to launch such a craft inside a solar system, even for science? Or would any near-light-speed vehicle automatically become too dangerous to exist near planets at all? Leave your answer below, because this is one of those questions where the engineering problem becomes a moral one. So what happens when a spacecraft traveling near light speed hits Jupiter? At 10% light speed, it is vaporized almost instantly, creating a violent plasma trail and a brilliant atmospheric disturbance. At half-light speed, it becomes a moving explosion, dumping enormous energy into the clouds before any recognizable structure can remain. At 99% light speed, it arrives already threatened by empty space itself, then converts into particle cascades, radiation, and shock waves on contact. At 99.9999% light speed, it is no longer useful to imagine a crash. It is an energy pulse with the memory of a spacecraft, absorbed by a planet too large to be impressed for long. In every version, Jupiter survives. In every version, the spacecraft does not. And the faster it goes, the less it resembles a ship hitting a world. At the edge of light speed, a spacecraft is concentrated consequence. For one fraction of a second, it becomes heat. It becomes radiation. It becomes a flash against the clouds of the largest planet in the solar system. Then the light fades. The shock spreads. The scar stretches into the weather. The atoms mix. And Jupiter continues, turning in the dark, wearing the impact for a while, then slowly, inevitably, making it part of itself.